When a patient suffers a stroke, the brain is suddenly deprived of oxygen. Every minute that passes, 2 million neurons wither and die. The immediate clinical problem is that an ischemic stroke, which is a blocked artery, and a hemorrhagic stroke, which is active bleeding, look identical from the outside, but they require exact opposite treatments. Giving blood thinners to a patient whose brain is already bleeding is fatal. Doctors need to see inside the skull immediately to know what to do, but seeing inside the skull requires loading a fragile patient into an ambulance and driving them to a specialized hospital, just to slide them into an immovable multi-million-dollar machine. We are losing the race against time to save brain tissue because our primary diagnostic tools are too large to leave the hospital. The machines anchored to those floors rely on extreme physical forces. CT scans blast the body with ionizing radiation, and MRIs use magnetic fields up to 7 Tesla, a force strong enough to rip a stray metallic implant right through soft tissue. Generating and containing forces that massive requires dedicated infrastructure, specialized supercooling systems, and immense power draws, all taking up an entire reinforced room. Relying on thousands of pounds of industrial hardware just to detect a blockage in soft tissue suggests our entire approach to measuring the human body might be overly complicated. In 1865, physicist James Clerk Maxwell proposed a theory that modern science often overlooks. The vacuum of space is not actually empty. This quantum vacuum has highly specific, measurable electromagnetic properties. If you measure free space, you will find it has a baseline resistance, an impedance of exactly 377 ohms. Space itself acts as a continuous medium. It can hold tension, store energy, and be mathematically mapped. The human body is roughly 60% water, and water interacts with electromagnetic fields very differently than empty space does. The human body has an effective impedance of about 42 ohms. Occupying space creates a massive 9-to-1 impedance contrast against the vacuum. This contrast varies across the body. Blood, bone, and fat contain different water percentages, projecting distinct electromagnetic signatures. From a physics perspective, the human body is a highly visible electromagnetic shadow cast against the quantum vacuum. A new medical device called Maxwell-Heaviside Aether Impedance Tomography, or MAIT, uses this exact principle. Instead of a rigid, claustrophobic metal tube, the hardware is a flexible, conformable cap lined with 256 simple patch antennas. To map the brain, the cap pulses harmless, low-power 2.4 GHz radio waves into the tissue. This is the same non-ionizing frequency band used by a standard Wi-Fi router. The array measures how those radio waves scatter and bend against the tissue 65,000 times per second. A neural network then processes those overlapping signals and reconstructs them into a high-resolution 3D volume grid in real time. By treating the human body as a local disturbance in the electromagnetic field, advanced math and ambient signal processing have replaced the need for giant magnets and radiation. This cost breakdown shows the financial impact of that shift. Because MAIT relies on basic radio components rather than supercooled electromagnets, an entire functional array costs about $1,950 to build, a fraction of the millions required for a standard MRI machine. This cost collapse makes medical imaging mobile. These caps can be placed inside neonatal incubators to monitor infants continuously, or carried seamlessly in the tight, restrictive quarters of standard emergency vehicles. Putting an imager in the back of an ambulance means a stroke patient can be scanned, diagnosed, and treated while still in transit, erasing the delay of hospital transport. The engineers at Inversion Labs who conceptualized MAIT made a radical decision. They released the complete design into the public domain under a Creative Commons Zero license. There are no patents, no restrictions, and no attribution required. Any engineer in the world can download the blueprints, build a prototype, and improve the software immediately. By releasing all the designs for free, Inversion Labs turned a sophisticated diagnostic tool into an open global utility, making the power to see inside our own bodies accessible to everyone.